Chapter 13, Section 2, for honors out of 2, talking about coterminal angles, standard position, and then radian measures. So first thing here, standard position. So in a coordinate plane, so right away coordinate plane, you should know your x and y axis. An angle can be formed by fixing one ray, called the initial ray, initial side, and rotating the other ray, called the terminal. So you have the initial terminal side about the vertex. We have the vertex point right here. Then we have the initial side. The initial side is on the x-axis. Then we have a terminal side. Terminal side is some ray that's been rotated off of the initial. So that movement creates this angle. And so that'd be the angle in standard position. So we're going to draw some angles in standard position. So 240. Initial is going to be on the x-axis. 240. So we go counterclockwise. So this is going to be 90, 180 to here, and then 270 would be the next quadrant. So we're not to 270. So 180, 270 would be all the way here. So I'm going to stop and call that 240. So for the second one here, 500, I can go all the way around the circle. That's 360. I still have 140 to go. So there's 90 right here. Another 50 degrees, and so this would be the terminal side. So notice I pass in a full circle and go past it. So negative 50 just means the opposite direction. So negative 50 is going to be about here. Coterminal angles is just when angles have the same ending position, maybe a different angle measured. Same terminal side. Different measure. They're different measures to create the same terminal side. So find one positive angle and one negative angle that are coterminal with. So we have negative 45. So negative 45 is here. It splits that 90 right in half. So it's a coterminal angle. So what could I do? I need a positive and a negative. A positive could just mean starting at the initial and going the positive direction all the way around. That's going to be 270 plus 45. So that would be 315. Now we need a negative. We already have the negative 45, but if we go past it all the way around and back to it, it's a different measure that ends up with the same terminal side. So that's just going to be negative 45 plus the 360s all the way around it. So we'll be at 405 negative. Radian measures. So angles, it's a different way of measuring angles. Angles can be measured in radians. So a radian measure is when the length of this radius ends up being the same as the arc length. So this outside measure right here, if I follow it along the circle, and this radius right here would have the same measure here, but we still have this angle would always be the same. So notice how this radius would also be a radius here. So all three of those really have the same measure. So that creates a 1 radian, and so here in red is 1 radian. We should know that the circumference of a circle is 2 pi r. So let's let a circle have a radius 1. If the circle has a radius of 1, then 2 pi would be its circumference. And so we take that 2 pi as the distance all the way around the circle, and we split it in. So 2 pi will go all the way around. Let's consider 2 pi radians then. That's how many radians would actually be in a full circle. We go half that, that's going to be 1 pi radians. So RAD is usually abbreviation for radians. So these two measures help us out with converting. We know that there's 2 pi radians in one unit circle, regardless of the radius. We just use the radius of 1 to make it easy to find that. But for all circles, it would be 2 pi radians for a full circle. Half the circle, then is only half of that, which is 1 pi radians. 1 pi radians is half the circle, so 1 pi radians is equal to 180 degrees. This is typically the conversion that we use to convert between degrees and radians. So down here, if we have 125 degrees, let's convert it to radians. So 125 degrees, I want to get rid of degrees, so I'm multiply by a fraction. Fraction has to be equal to 1. So I'm going to put degrees in the denominator, so 180 degrees. Since the fraction has to equal 1, I have to put an equivalent to it on top, which I'm going to put 1 pi radians. So those are the same thing, so this fraction is equal to 1. The degrees, the units reduce out. This degree and this degree reduce out. And now I end up with radians, and I just need to reduce my numbers here. So I know 5 goes in both of these. So this ends up being 25 pi 36 radians is equal to 125 degrees. Let's do another one. Let's go the other way. Let's take the negative pi 12ths. That's in radians. I'm going to multiply by a fraction. I'm going to put the pi radians in the denominator and put 180 degrees in the numerator. Now when I reduce this, the pi's reduce out, and I can reduce the 12 and the 180 by 4. So I get negative 45 thirds, which I can actually divide that. I get negative 15 degrees. So negative pi 12 is the same thing as negative 15 degrees. Okay, so now we're going to start looking at the unit circle a little bit. We're going to look at more of the angles today, then we'll actually start plotting points on the unit circle tomorrow. But for this, we're going to look at the unit circle. We take our two special right triangles. We have the 30, 60, 90. We have the 45, 45, 90. And if we take the 30, 60, 90 and we flip it around, and so we put the 60 here, those are the 3 different triangles I have in here. And so those are the kind of triangles we try building within the unit circle. So the angle measures we're looking at here, that's what we're going to look at first here. I teach students by thinking about pizza. I want to split it into equal pieces. And the first thing I have them do is split it into 8 equal pieces. So in this pizza right here, I have it split into 4 equal pieces. So if I want to make it 8, I would just divide each of these in half. And so when I do this, approximate here, I can then find my angle measures. So let's work backwards here. If I go all the way around the circle, that's 360 degrees. So let's work backwards. Go half of that, that's going to be 180 degrees. If I go half of that distance is up here, it'll be at 90 degrees. If I go half of that, I'm at 45. So we already knew this is the 45, 45, 90 triangle, but I like working backwards so you can find that. It'll help us when we start looking at radians. So then we're looking at multiples of 45. So 45 plus 45 is 90. 90 plus 45 is 135. I'm just using my multiples to help me find the next angle. 135 plus 45 is 180. 180 plus 45 is 225. 225, we're at 270. At 270, we're at 315 degrees. And then back to 360. So those are the different measures at the 45s. So each of these separation between these pieces would have an angle of 45, or a central angle of 45 degrees. We can do that again, but instead of splitting into 12 equal pieces, or instead of splitting into 8 equal pieces, let's split it into 12. A little more difficult. We still have the one that splits it into half and then into quarters, so that's fine. But if I want to split it into 12, then each of these quarters needs to contain 3 pieces. 3 times 4 is 12. So I need to split this quadrant into 3 equal pieces. So I know it's 90, so I break it into 3. I'm about here at 30 degrees. So I'm going to have another one up here, another one. And then my next quadrant, same thing. I have to split it into thirds, about here. And one last one. So the red lines give us 12 equal pieces of pizza. So we have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so we can work backwards now to figure out those angles. So 360 is still all the way around. Then half of 360 is still 180. Half of 180 is still 90. And then 90 is broken into 3 equal parts. So 95 by 3 is 30. I'm doing multiples of 30. 30 plus 30 would be 60. Plus 30 is 90. Plus 30 is 120. 150. 180. 210. 225 or 240. 270, 300, 330, and 360. So then those are all of the angle measures of the unit circle that you're going to be learning tomorrow, but you have to be able to first build it, these angles. So these are all the different segments we're going to draw. Now these segments, what they mean, they end up representing triangles. So you can see how we have a triangle in here. This is the 30, 60, 90 triangle. We should see within this picture. Now we can build this same exact thing with radian measures. Remember, one unit circle or one circle, every circle has 2 pi radians all the way around. So if I go half of that, this is equal to 1 pi radians, and that's what we use to convert. If we do half of that, this is pi halves. If we do half of that, this is pi fourths. So the 45s are equivalent to pi fourth radian. And so then if we're going to go around this circle and do multiples of pi fourths, that's 1 pi fourths, 2 pi fourths, which is 1/2, 3 pi fourths, 4 pi fourths, which is the 1 pi, 5 pi fourths, 6 pi fourths is here, but if I reduce 6 pi fourths, it's 7 pi fourths, then 8 pi fourths is the 2 pi. Now we can do that same exact thing, but we can do it with the 30. So we can work our way back around to the pi halves. Now pi halves, this is split into 1, 2, 3 equal parts. So I do pi halves times a third, I get pi 6. This is pi 6. Now do multiples of pi 6. 1 pi 6, and we're doing the red ones here. 1 pi 6, 2 pi 6, which is a pi thirds. So it's 1 pi 6, 2 pi 6, 3 pi 6 is pi halves. 4 pi 6, which is 2 pi thirds. 5 pi 6, 6 pi 6, 7 pi 6. 8 pi 6, which I can reduce that 4 pi thirds. 9 pi 6, which I can reduce. 10 pi 6, which is 5 pi thirds. And 11 pi 6. So these are the radian measures that match all of the degrees. You could have converted on one, but I like to use the multiples. It ends up being faster once you really realized what segments are related to the other segments. So this is the same exact circle we drew. It's kind of nice and pretty for you, so you can see the different measures, the angles and the radian measures. Arc length and the area of a sector. So we really just use this formula. Well, arc length S is the arc length out here. S is equal to the radius times theta, where theta has to be in radians, measured in radians. Area of that is equal to 1/2 r squared theta. So it's how to find the area and the arc length of a region, of a portion of a circle. So an example here would be a softball field, and we can look at finding the length of the outfield fence and the area of the field in its entirety. And so if we know that the radius is 180 feet, and we have a 90-degree angle here, but we don't use 90 degrees, we have to convert that. That's pi half radians. If you don't remember that, you can actually go through and convert it again. But to find the arc length S, it's equal to the radius 180 times pi halves. And so that's going to be 90 pi, and then that would be the arc length, and that would be feet. The area is going to equal 1/2 times the radius squared times theta, which is pi halves. 180 squared, and I'm going to divide it by 4, and you get 8100. And that's still multiplied by pi. So this would be feet squared. And those are exact values. I'm going to stop there, call it good. Next portion tomorrow will be the unit circle.